So next to our two problems, actually I don't know, something happened to the presentation. The font and all got changed. I'm trying to fix it, but it's not coming. So whatever, you can read all these things. Some justification gone, it's okay. So you go through the question first. There are few terms that you are unknown to you, so you just go through that. Involute gears, pressure angle, number of teeth on pinion, pitch expressed module. Then pitch line speed. Okay, the third line, pitch line speed is 1.2 meter per second. That is one term you're not familiar with. Pitch line speed is nothing. When we say pitch, we can imagine pitch circle and pitch point. Therefore, pitch line speed is actually the the velocity at pitch point. So when we consider the pitch point, what will be the velocity? Omega 1 into R1, or that is equal to omega 2 into R2. So you note down pitch line speed is, before the problem I think you can note down all these. Pitch line speed equal to small r into omega 1, that is also equal to capital R into omega 2, or R1 omega 1 and R2 omega 2. So when I say R omega 1, that is for pinion and wheel, that's all. Okay, nothing to confuse. Okay, you got it, right? Then next, assuming addendum standard and equal to one module. When we say assume addendum is equal to one module, means the value of addendum is one module. One module is 5 mm. So addendum will be 5 mm. That is Ra minus R is 5 mm in both cases. And next term is not familiar. Term is angle turned by pinion when one pair of teeth is in mesh. So what is angle turned by pinion? You can just imagine we have the arc of contact. So arc of contact is corresponding movement in along pitch circle. That's the arc. So it is simple. You have to find the corresponding angle instead of the arc. So what's the relation between arc and angle? Just write arc length equal to corresponding angle into radius, right? So here question is pinion, so the radius should be of pinion, small r. So you can write angle turned by pinion equal to arc of contact, length of arc, that is here is the arc of contact divided by radius of pinion. So this is the angle in radian. Okay, unit is radians. So usually you need it in degree. So how will you change to degree? 360 by 2 pi. So I will again tell, all this you have to note down. Okay, I am not writing it here. Just note down what angle turned by pinion equal to arc of contact divided by R into 360 by 2 pi. So you can combine 2 pi and R in the denominator. That means 2 pi R. What is 2 pi R? Circumference of pinion. So it can also, you can write it as arc of contact into 360 degrees divided by circumference of pinion. This is the expression provided in text. We know how this expression came. So this expression or the previous one you can use to find angle turned by pinion. That also you note down. Should not a heading angle turned by pinion, then write this expression and put both are in boxes. Okay. Then maximum velocity of sliding. That is another important thing. Here we already discussed sliding velocity. I think below that, if you didn't write the other thing, you can first you write the maximum sliding velocity concepts here, then you can write the other two. Otherwise you can write after that. I'll tell you what is the maximum velocity of sliding. So sliding velocity equation is this: omega 1 plus omega 2 equal to q into p. Omega 1 and omega 2 are fixed velocities. So the change is only to qp. What is qp? The distance between q to p. Q is the point of contact at the one instant, and p is the invariable point, pitch point. So the distance from pitch point is the only variation in sliding velocity calculation. So what is the maximum distance this Q can move? That is a question. You see the line MN, that is a common tangent, that is along the path of contact only. And what is path of contact? You remember the previous diagram, you have to refer. You cannot go back. This is another PPT. So you go back to your book and check that diagram and listen. Okay. Path of contact is represented as KL. So this Q can move up to K on one side, then Q can move up to L on the other side. So K and L are the extreme points where this Q can reach. So what will be the corresponding velocities? When it is at K, the sliding velocity will be omega 1 plus omega 2 into Kp. Similarly, at L, it will be omega 1 plus omega 2 into PL. Okay. So either one of these velocities will be your maximum sliding velocity. That you have to find. Which one is maximum? That you have to find. Either Kp or PL will give you the you have to find Kp and PL. The larger value will give you the sliding velocity. Now I said Kp and PL. What is Kp and PL? Again, you go back the same with the same diagram. You have the derivation. You go through the derivation. We found KL, the path of contact, as the sum of Kp and PL. So you have an expression for Kp. You are also having an expression for PL. So you have to use that expressions to find Kp and PL. And also note one more point. What is Kp? For that, you remember the definition of arc of contact. Arc of contact is defined as sum of arc of approach and arc of recess. What is arc of approach? From the beginning of engagement to pitch point. Similarly, arc of recess is the pitch point to end of engagement. So Kp represents, K representing the beginning, P is the pitch point. From beginning to pitch point. So Kp is the path of approach. Please note down somewhere, either back at or here. Kp is path of approach. Similarly, PL is path of recess. So in this question, you have to find path of approach and path of recess. If path of approach is higher, you will get the maximum sliding velocity at K. So you have to multiply omega 1 plus omega 2 into Kp. That's all. Okay. So these are the terms. So note all these expressions and put in appropriate boxes. Then you come to this question. Okay. Question, phi pressure angle is given, phi 20 degree. Number of teeth on pinion is given, t, small t is 20. Now gear ratio is nothing. It is a ratio of teeth of wheel to pinion. Number of teeth of wheel to number of teeth of pinion. That is capital T by small t. Therefore, what we can say, capital T is equal to 20 into 2, 40. The gear ratio definition also you can note somewhere in a box. Then if pitch expressed in module is 5 mm, pitch line speed is 1.2, module is given, addendum is given, then that pitch line speed also given. Pitch line speed is R omega 1 or R1 omega 1 or R equal to R2 omega 2. So how will you start? For the first part, you need angle turned by pinion. So that expression contain arc of contact. Therefore, you have to find arc of contact. To find arc of contact, you have to find path of contact. So you find path of contact. What all required for path of contact? Capital Ra, small ra, capital R, small r, and phi. Now phi you have. What about capital and small r? You have module 5 mm. What is module? D by T. Therefore, you will get capital D and small d from this equation. What will be capital D? 20 into 5, 100. Similarly, small d you can small d is 100. Capital D will be 200. So you will get small r and capital R. Then what is addendum? Addendum is given as equal to 1 module, that is 5 mm. So R plus 5 will give you Ra. So you got all the required parameters, then substitute it and find path of contact, then find arc of contact, then substitute in the equation arc of contact by 2 pi r into 360, you will get angle turned by pinion. Then to find maximum velocity of sliding, you find Kp and Pl separately from the path of contact expression. So probably Kp will be higher, so Kp into omega 1 plus omega 2 will give you maximum velocity of sliding. And how will you find omega 1 and omega 2? You have pitch line speed as 1.2. So 1.2 equal to omega 1 into pinion radius, right? Or omega of pinion equal to pitch line speed equal to omega of pinion into pinion radius. So pinion radius is already known, pitch line speed also known, so you will get omega pinion. Similarly, you will get omega of field. So the sum of angular velocities into Kp will give you maximum velocity of sliding. A similar question, I will not explain it, just do it. Wait. Determine the velocity of sliding between gear teeth faces at the point of engagement, pitch point and point of disengagement. Here again the question is to find the sliding velocity of point of engagement. What is the point of engagement? The starting point, that is K. So what is the corresponding sliding velocity? Omega 1 plus omega 2 into Kp, that you have to find. At the pitch point means, what is the sliding velocity at pitch point? Sliding velocity is defined as the with the distance from pitch point. So when the distance equal to 0, there will be no sliding velocity. So at pitch point, sliding velocity will be 0. That is answer. At the point of disengagement means point L. So you have to find omega 1 plus omega 2 into PL. Then same point, angle through which pinion turns. That you have to use the previous expression, arc of contact. Then for that you have to find path of contact. So similar question, so find it. Okay. So next topic is interference. So next interference. Okay. That is last topic on this session, gears. Now again that familiar diagram for you. It's representing the path of contact and tangent, Mn, Kl, pitch point, C1, C2, etc. So the question, you read this question, what happens when addendum radius of gear 2 is increased to 0.10? Now what is the addendum radius? Addendum radius is from C2 to this A2, right? C2 to this. C2 to this point, clear? This is C2 to that point. That is the addendum radius, you know. So when it is increased to n, okay, when it is increased to n, what happened? So what is n? You know that n is a point on base circle. That what you have to understand is M and N are points on base circle. And what is base circle or root circle? Where the teeth profile starts. K and L are not points on base circle. Maybe in our diagram you may feel so. K and L are also point on base circle, but it is not so. What are the points K and L? They are the points where the addendum circle of the mating gear cuts the common tangent. So it will be slightly beyond base circle, not on base circle. But M and N are on base circle. Now you imagine we are increasing the addendum radius to N, or similarly the other case, addendum radius to M, C1 to M or C2 to N. Then what happen means addendum of one gear reaches the base circle of the mating gear. Okay. addendum of, now what happens when it is increased to point n, not increased beyond point n, slightly beyond n means the addendum circle reaches below the base circle of the mating gear. That means we called the addendum tip of the tooth undercut the profile of the, or undercut the tooth of the mating gear. Such a phenomenon will happen. That is called interference. Clear? It is simple. Actually the addendum not reaches base circle, that means not reach the root of the teeth profile, but when it at usual cases, but when it is increased to n, it will exactly reaches the root of the profile. When it go beyond n, it go inside the profile, that means undercut the profile. So that is called, that should be avoided, and that is called interference between gears. Okay, so read, tip of tooth undercuts the root on its mating gear is known as interference. So what you have to study is the minimum number of teeth on each gear to avoid interference. Okay, that you should know, and derivation and all are not required. So only thing you have to study the equation. This is the relation. Now you study both expressions. One is for small t, that is teeth on pinion, and other one is teeth on wheel. So I will read it. T equal to 2ap divided by root of 1 plus t by t into t by t plus 2 sin square phi up to sin square phi is in the root minus 1. Now t by t is gear ratio. Gear ratio is represented as g. Note down that. Then phi is your pressure angle. Then AP and the second expression, same thing. Terms are same, but instead of g we have 1 by g. So two unknown terms are AP and AW. What is AP and AW? AP is corresponding to addendum of pinion in terms of module. Clear? It is not the correct addendum. It is addendum mentioned in terms of module. The previous question you remember, addendum equal to 1 module. Like that we will specify. Then AP will be 1. If addendum is half of the module means AP will be 1 by 2. Similarly AW. Okay. So these expressions please note down, put in boxes. So with this you have to do 2 more problems. What's the question? Determine the minimum number of teeth required on a pinion in order to avoid interference, which is to gear with a wheel to give a gear ratio of 3 to 1 and to an equal wheel. So in first case t by t is 3, next case t equal to small t. The direct question, just substitute in this. First case you have t by t, you have to substitute as 3. Second case you have to substitute as 1. Question is minimum number of teeth required on pinion, so you have to find small t, and it's given that addendum, standard addendum of 1 module, that means AP is 1. Okay, clear? So do this. Then problem 7 and 8, last 2 problems. Similar questions. A pair of involute spike gears with 16-degree pressure angle. So phi is given. Then module 6 mm. Module is given. Number of teeth on pinion is given. Pinion speed is given. That is N1 is 240 RPM. So omega 1 will be 2 pi into 240 by 60. Gear ratio is 1.75. Find, in order that the interference is just avoided, what you have to find is at the instant where interference is just avoided. So again that term is important. Many questions you may see that interference is just avoided. Interference is just avoided means what? Where will be that point? That's my question. It is just avoided means the addendum radius increased up to n or m. Okay, when the addendum radius is less than n, it is safe. At n means it is the beyond n means it undercut and interference occur. So that point where it is just avoided means it is equal to C2n, addendum radius equal to C2n or C1n. Why they asking that means at that case you can use this equation and find all the required things. That is, number of teeth already given, 16, and that case is interference is that case is equivalent to interference is just avoided. That means this is the minimum number of teeth. That is observation. So the given number of teeth is actually the minimum number of teeth to avoid interference. Therefore, we can substitute in this equation. This t equal to 16 we can substitute in this equation. So the unknown will be AP. So you will get AP. That is addendum in terms of module. So that multiplied with the module value will give you addenda on pinion. Similarly, when do it in the other expression, you will get for wheel. Then you have to find length of path of contact and maximum velocity of sliding. That is continuation of the previous problems. Similarly, one more question. Okay. So do all the 5 questions you have. All 5 questions you do. And if you have any doubts, you can ask. That's all for today. Okay. Thank you.